I am Dr. Mahammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today I want to discuss about computer network subject, in which the topic is OSI model transmission media. Here, the outcome of the OSI model transmission media is the OSI model, which defines the framework for communication across the network, while transmission media, which serves as a physical channel for the data transfer between the devices in a network. This is the outcome of the transmission media. The OSI model transmission media. The transmission media is a communication channel that carries the information or data from sender to receiver. Here it is a sender and which one is the receiver. Generally, through the transmission media, the transmission media in a OSI model of the transmission media, via this transmission media, we can sending the information. We can sending the data from sender to the receiver. Here, that can be done over the physical layer. That means the main the functionalities of the transmission media is to carrying the information in the form of the bits through the LAN, local area network. Here, these are the correct transmission media. Now you can utilize the cables or any electromagnetic waveform. We can transmitting the data or signal, whatever the data, whatever the information you are transmitting, it will be transferring the data from sender to the receiver in the form of the electromagnetic waveform. So it is a physical path between the transmitter and receiver in a data communications. So this is about the transmission media. And generally, in a copper-based network, the bits in the form of the electrical signal can be utilized. And in a fiber-based network, in a transmission over the transmission media, the bits in the form of the light pulse can be utilized. Here, if the network is a fiber-based network, light pulses can be utilizing. If the network is a copper-based network, while communicating between the two devices here, now you can utilize the electrical signals. Electrical signals can be utilized. OSI, that is open system interconnection phase. The transmission media always which is supporting the layer 1. Here also physical layer. Layer 1, it is nothing but it is a physical layer. By supporting of this the physical layer, we can transferring the information from one device to the another device. That's why the layer 1, the physical layer 1 now we can utilize while transmitting the information over the transmission media. It is considered to be the layer 1 component. Here, if you see the cabling, now we are generally over this transmission media, the cabling now generally we are utilizing the copper cables or optical fiber cables. The electrical signals can be sent through the copper wire and fiber optics or atmosphere, water or vacuum. Generally here, the electrical signal can be transferred through the copper wires. Any fiber, the optics or any atmosphere, water or vacuum, through these the things electrical signal can be transmitted. The characteristics and quality of the data transmissions are determined by the characteristics of the medium and other signal. Medium and signal with help of this the transmission medium, and what type of these signals we are transmitting through these the copper wires, through this the cabling, with help of this transmitting and the signaling, the characteristics and the quality of the data transmissions can be determined. The performance of the data transmission also we can determine. Generally, the transmission media is of two types. That is, one is a wired media, another one is a wireless media. Two types of the transmission media is there. These are the wired media, also we can call it as a guided media. Guided media, it is a connection oriented by establishing the connection, now will transferring the information. Wireless the media, it is a unguided media. Unguided media means without the connection establishment, the communication can be established in a wireless media. Here in a wired media, medium characteristics are more important, whereas in a wireless media, signal characteristics are very important. So this can be considered. Different transmission medias having the different properties, such as the transmission media. So that means now which is varies, depends upon the bandwidth and the delay, cost, and installation and maintenance of the network. Based on these different properties, now the transmission medias are varies. Here, the transmission media is available in the lower level of the OSI reference model. That is a physical layer is a lower layer of the OSI reference model. Over this lower level layer, now we can transmitting the information. That means here the data can be transmitted, or information can be transmitted in the form of the bits. That is 10, 10, 111. So like this, in the form of the binary, or in the form of the bits over the physical layer, the data can be transmitted from one device to another device. Some factors needed to be considered for designing the transmission media. The factors are bandwidth can be considered while transmitting the information over this other network. The bandwidth will be considered. So this bandwidth of the media, the hiring the data transmission rate of the signal. That means now data, bulk amount of data or less amount of data, that should be the varies, depends upon the bandwidth of the transmission media. If the bandwidth is a more, the bandwidth now, the data transmission can be increased. If the bandwidth less, the bandwidth reducing the data transmissions over the network. And the classifications of the transmission media. Transmission media mainly, which is divided into two categories. That is one is a guided transmission media, another is a unguided transmission media. Guided transmission media is nothing but it is a connection oriented transmission between the devices. Unguided transmission media, it is a wireless transmissions. Wireless the transmissions can be done between the different devices. Here again these connection oriented, that is a guided the transmission media, again can be categorized into the for this the guided transmission media. Now again we are categorized coaxial, fiber optics, and twisted pair. That means the connection orientation can be done by using the coaxial cables or fiber optics or other twisted pairs. The connection establishment can be done between the two devices. Again here this coaxial cable, which is categorized into baseband coaxial cable, broadband coaxial cable. Two types now we are categorizing. Twisted pair cables. Twisted pair cables are, so these the pair cables are the unshielded the pair cables and shielded pair cables. Now we are again, which is categorized into two types. And unguided media, radio waves. Unguided media are the radio waves, microwaves, or infrared waves. So this is unguided medias. Now, so these today now we are discussing the only the guided media, the transmission. Here the difference between the guided and unguided media. That means guided media, if we take the guided media, the communication or bounded the transmission media. That means here in this the guided media, the communication should be the bounded. But the unguided media is also called as it is a wireless the communication, but unbounded the transmission media. That means for particular the distance now which is having the which is transmitting up to the particular distance the guided media, but unbounded the transmission media means now, so there is the no other boundaries now, and that is comparing this the guided media, so that means which is transmitting the signal, which is transmitting the signal now, that means the wireless wireless the signals, that is a wireless communication can be established. So that means there is no other bounded to particular the kilometers, but here any to suppose here if it is transmitting up to 20 kilometers, but it is not bounded to 20 kilometers, it may be transmitted to 100 kilometers or 200 kilometers, 300 kilometers, that is a unbounded media. This unguided media is a unbounded media. Why? Because it is a wireless the communication media, and the signal energy propagates through the wires in a guided media. That means here the wires is required. Why? Because the guided media is a connection oriented. With help of this the wires now it will be connected. These the devices will be the connected. Here is the signal energy which is the propagates through the air or unguided media. Through this air, the transmission media, it may be the cabling or air. If it is unguided, the transmission media is a air. If it is guided, the transmission media is a wired. Here, in guided transmission media, used to performing the point-to-point communication. That means point-to-point the communication is nothing but a computer mission to computer mission or host to host communication can be done in a guided media. But in a unguided the media is generally suited for the radio broadcasting in all directions. Here, why? Because now it is a wireless the communication. So it is affordable. That means the connection, the guided media is affordable. So this one wireless it is a very costly. And guided media, if you take the guided media, discrete network topologies are formed by the guided media. But the continuous network of the topologies can be utilized in a unguided media. It will be formed. That is the network of the topologies are continuously transmitting. But here the transmission in a guided media discrete. The network of the topologies are the discrete. Now we can't transmit the continuous data. We can't transmit the continuous informations. Here guided media signals are in the form of the voltage. Signals can be in the form of the voltage, current or photons in the guided media. Generally, we can transferring the signals. Signals are in the form of the electromagnetic waves in a unguided media. That means whatever the data you are transmitting, that the transmitted data can be transferred through the transmission media in the form of the electromagnetic wave. Here in a guided media, by adding more wires, the transmission capacity can be increased in a guided media. So the transmission capacity, if you want to increase the transmission the capacity, now you have to add the more cabling is required. But it is not required. A cabling is not required in a unguided media. It is not possible to obtain the additional the capacity. So in a unguided media, so it is not required any cabling. But here the capacity can be improved. But the performance in unguided media, the performance and accuracy can be improved. Guided media which sends out the signals which is indicating which way to going. That means so in a guided media here clearly we can know the signals is going in a which way now we are the transmitting the signals. That is the guided media. In unguided media now it doesn't indicate which way to traveling the signals. So in unguided media, so it is not the correct. So that's why it doesn't indicating which way to traveling the signal, in which the direction we are traveling the signal. So we can't identify it in a unguided transmit. That means wireless the communication. Once releasing the data or information into the air, we can't to identify where the data is moving, where the data is going here. We can't identify in a unguided transmission of the media. For a shorter distance, so this is the best option. For distance very short the distance, for limited the distance, the guided transmission media is better. For longer distance, this method is can be utilized. That is the global the communication. Global communication can be done with help of the unguided transmission medias. So it is unable to pass through the walls. It can pass through the walls. So this is the differences between the guided transmission media and unguided transmission media. So that guided transmission media, which communication is a very essential component of the vast field of the computer network. Computer network now, these are the guided transmission media. It is a very essential component. That should be depends on the variety of other transmission methods. So to enabling the data exchange, for enabling the data exchange now, different types of the transmission methods can be utilized. So in this the procedure now, guided transmission media so is also referred to as a bounded or wide media. Bounded or wide. That means a wide media. So it is nothing but it is a connection oriented. Connection oriented between the device to device or point to point. Types of the guided transmission media. So twisted pair cabling. In twisted pair cabling, so it is a physical media made up of pair of cables. It will be twisted with each other. So this is a twisted the pair cabling. The twisted the pair cabling is very cheap as compared to the other transmission the medias. For example, here it is phone calls. Landline phone calling. These are the cabling. That is a twisted the pair cabling can be utilized. Installing of the twisted the pair cabling. So it is very easy. It's a lightweight the cables. Now here lightweight cables can be utilized. The frequency range for the twisted cable is 0 to 3.50 kilohertz. Landline phones. Best example for twisted pair cabling utilization is a landline the phones. Characteristics of the twisted the cabling. Now the twisted pair cabling have become the more common in a LAN and phone lines. Landlines. If you take the landlines or any telephonic lines, now these are the twisted the pair the cablings can be generally utilized. These are all the available in a two types of unprotected twisted pair and shielded twisted pairs. These two types generally we are utilizing. A twisted the pair now, which is consisting of two insulated copper wires. Insulated copper wires arranged in the regular spiral patterns. So this is a twisted pairs. Twisted pairs can be arranged. That is these two insulated with the copper wires. This can be copper regular spiral patterns. That can be we can manage. This is a twisted the pairs. Outside now, the twisted pair outside we can arrange the jocket. These are the jocket now, which is the protecting the whatever the wires are the twisted. Paired wires are the twisted. That will be the protected with help of the jocket. That is cover to the twisted pairs. Types of the twisted pair is unshielded twisted pairs or shielded twisted pairs. Again it is categorized into two types. That is a unshielded twisted pair is one, another one the shielded twisted pair. If we see the unshielded the twisted pair, so what is a unshielded the twisted pair? Mainly these unshielded twisted pairs are used in a telecommunication. Any telecommunication network, BSNL, with other connectivities now generally. So these unshielded the twisted pairs can be utilized. Generally here, the categories of the unshielded the twisted pair, the pair cabling are first the category 1. In category 1 now, category 1 is used for telephonic lines. Any BSNL telephonic line, ground under this ground some of the telephonic line the constructions is good. That is a one category one that have the low speed data. Whatever the underground level we are constructing the telephonic other lines now, which is having the speed is very low. Category 2, it can support up to 4 Mbps data. Category 1, less than 4 Mbps data. That means 2 Mbps up to 2 Mbps data now, which is supporting. So that's why the speed is very low. Category 3, now it is support 16 Mbps data. Category 4, it can support 20 Mbps data. Category 5, which is support 200 Mbps data. These are different other categories. Unshielded twisted pairs that can be categorized into different other categories. The advantages of the unshielded twisted pairs are it's a very cheap. So the market now, if you see, it is very cheap. Installation of the unshielded the twisted pair is very easy, comparing than the another cabling the installations. It can be used for high speed local area networks. Disadvantage is these are the cable can only be used for shorter distance only because of the attenuation. Because of this attenuation now, which can be used very shorter at the distance. That may be it may be used up to 10 kilometers or up to 20 kilometers. The limited the bounded distance only. These are the cable can be utilized. That means the usage distance is very bounded. Shielded twisted pair. Shielded twisted pair is a cable that contains the mesh surrounding the wire that allow the higher transmission rate. That means here these shielded twisted pairs are the rate of the transmission is a very high comparing than the unshielded twisted pairs. The characteristics of the shielded twisted pairs are the cost of the shielded twisted pair cable is not very high, not very low. So medium. So here is the cost of the shielded twisted pair is medium, not very high, not very low. And the installation of this STP is very easy. Shielded twisted pair. STP means shielded twisted pair. The installation is very easy comparing than the unshielded twisted pair. It has a higher capacity as compared to the unshielded twisted pair cabling. So better these shielded twisted pairs are it's a better which is having high performance than the unshielded twisted pairs. Always now preferring unshielded shielded twisted pair is the better. Why? Because now which is having the high other performance and it has a higher the attenuation, which is having the higher attenuation. So it is shielded that provides the higher the data transmission rate comparing than the unshielded twisted other pairs. The advantages of the shielded twisted pairs are which is reduce the electromagnetic interference. This is a advantage. This is one advantage, that is a EMI, electromagnetic wave. The interference can be reduced. That means minimizing the external interferences and enhancing the signal the quality with help of the twisted pairs and improving the security. With help of these, the mechanisms are authentication and authorization mechanisms. Now, which improving the security. Why? Because the core the transmission media is a shielded, which is protected by the outer layer. That's why now which very secure also. The security now we are providing very high security. The shielding helps to preventing the signal leakage. Signal leakage, if any signals are leakage can be prevented, and offering the better data security. Same here, if you take the unguided transmission media, then unguided transmission media now will provide the secure. How we are providing the security means with help of the encryption, decryption and the technology, we can provide the security in a unguided transmission media. But here is now the shielding. With help of the shielding now, we can preventing the data leakage. A signal leakage can be prevented with help of the signaling. Higher a transmission rate. If you take the transmission rate higher, these shielded the shielded these twisted pairs, whatever the shielded twisted pairs you are using, that can be support very fast, very the fast data transmission compared to the unshielded twisted the pair cabling. So that's why shielded twisted pair cabling is a better than the unshielded twisted the pair, especially which is having the high noise environment. Noise environment should be very high. Enhanced durability. Enhanced durability, that means the additional shielding layer, that is which is increasing the cabling protection and durability. That means the better the performance in a longer distance. That is a STP, shielded twisted the pair, which is the performs the better over longer distance compared to the unshielded twisted pairs. Now if we take the unshielded twisted pairs, now if it is supporting only up to 20 kilometers, 20 kilometers are the supporting with help of the unshielded the twisted pairs. Now with the help of the shielded the twisted pair, more than the 20 kilometers, now we can we can up to more than the 20 kilometer distance, so that can be covered. So data transmission can be done more than that, means 30 kilometers or 40 kilometers. More than this is the unshielded twisted pair, which is transmitting the data. So the disadvantage of these shielded the twisted pair means it is more expensive as compared to the unshielded twisted pair or coaxial cables. It is having the higher the attenuation rate. So these two are the disadvantages. Coaxial cables. Coaxial cable is a very commonly used transmission media. In a society, the coaxial cables are very commonly used. That means, for example, TV wires is usually as a coaxial cable. TV wires are the coaxial cables. The name of the cable is a coaxial. Now it contains the two conductors parallelly to each other. The conductor should be in a coaxial cable. Two conductors should be parallelly to each other. Now it has higher the frequency as compared to the twisted other cable. The frequency should be very high. Comparing with the other cablings. Here, if you see, this is the coaxial diagrammatical the pictorial representation. That means inner conductor. So this is the inner conductor. Central the conductor, we are saying it as a inner conductor of the coaxial cable. Now is made up of the copper. Now it is made up with the copper. Now it is made up with the copper. So this is a inner conductor, and the outer conductor is made up of the copper mesh. This is a copper mesh. Now outer sheath are the copper mesh, and this middle core is made up of the non-conductive covers. Now here is a dielectric insulations and braid the screen. Now these are all the non-conducting the materials, now which is made up of the non-conductive covers that are separating the inner conductor from the outer conductor. Inner and outer conductor, now it will be separated. The middle core is responsible for the data transferring, whereas the copper mesh is preventing from the electromagnetic interferences. So here is this is a coaxial the cabling, the pictorial representation. If you see, now coaxial cabling, it is having the two types. That is one is a baseband coaxial cabling, broadband coaxial cabling. So that means baseband coaxial cabling, that is a baseband the transmission can be performed with help of the baseband coaxial cabling. So it is defined as the process of transmitting a single signal at a high speed. That means the signal can be transmitted very high speed with help of the baseband This is the coaxial the cabling. Broadband cabling. Broadband the cabling now, which is defined as a process of transmitting multiple signals simultaneously. But here, in a baseband signal, the difference is single signal we are transmitting. In broadband signal, multiple signals simultaneously can be transmitted. The advantages of the coaxial cabling: mainly data can be transmitted very high speed. The data rate is a very high speed. So with high speed now, the data rate, the accuracy, the transference accuracy can be improved. It has a better shielding as compared to the twisted pair cabling. If you compare to the twisted pair cabling, the shielding is better. Why? Because now, which is with better shielding, which is providing the more security. The data leakage can be avoided with help of the better shielding in a coaxial cables. It provides the higher bandwidth. Whenever the bandwidth is high, the speed also automatically it will be increased. That's why the higher bandwidth always now, which is the proportional to speed, bandwidth which is proportional to speed. The bandwidth is increases, the speed also increases. Disadvantages of the coaxial cable. Here, coaxial cable, so these are the more expensive as compared with the twisted cables. If any fault occurrence in the cabling, if any faults or any errors are arised in the cabling, the failure in the it will be failed in entire the networking. Fiber optics. Fiber optics cabling is a cables that use the electrical signal for communication. Electrical signals for the communication. For with help of these fiber optic cables now, electrical in the form of the electrical signal. In the form of the electrical signal here, in the form of these, the electrical signal. Now we can transmit the data from one through these fiber optic cables. Through this fiber optic cables here, in the form of the electrical waveform, the signals can be either transmitted in the form of the analog or in the form of the digital. Here now we can transmit the data. Fiber optic is a cable. So these the fiber optic cables can be created by using the plastic. For creating the fiber optic cables, we can utilize the plastic that are used to sending the data by pulse of lights. With the pulse of lights now, we can sending the data. Plastic coating now, whatever the coated, the plastic is coated, which is protects the optical fibers. Optical fibers now, which is protected from heat or cold or electromagnetic interference. Here it will be protected from the heat, cold or electromagnetic interference from the other type of wiring. Fiber optics now, this fiber optics now is providing the faster data transmissions than the copper wires. Why? Because the comparing with the copper wires, the bandwidth is very high in a fiber optics. Basic elements of the fiber optics are: this is a core, the core, and this is a cladding, and side view. This is a jacket. Inside the jacket, the cladding now can arrange. So inside the cladding now the core. So this the core is a optical fiber consistent of narrow standard of glass or plastic is known as a core. A core is a lightweight transmission area of the fiber. It is a very lightweight transmission area. Core. This the core is a very lightweight transmission. The more area of the core, so that means the light will be transmitted into the fiber. And the view here. So this is the end view of the transmission. So cladding means now the concentric layer of the glass is known as the cladding. That means the main functionality of the cladding is to provide the lower refractive index at the core in the interface as to cause the reflection. with a core, so that the light waves are transmitted through the fiber. Light waves now we can through this the fiber, the light waves can be transmitted. Light waves can be transmitted. Jacket. So in this now the next the thing, the jacket now, always this jackets is a protective coating. This jacket is a protective coating. So which is the protecting the consisting of the plastic is known as a jacket. Is always protecting the cladding and core. With help of the jacket, the cladding and the core will be protected. The main purpose of the jacket is to preserving the this is the strength of the this is the fiber, and absorbing the shocks and extract the fiber other protections with help of the jackets. Advantages of the fiber optics cabling over the copper. The advantages is the bandwidth is a very greater bandwidth, very high bandwidth. That means which fiber optics now which is providing the more bandwidth as compared the coppers. The fiber optics now which is carrying the more data than copper the cabling compared with the copper cabling. Faster speed. That means if the bandwidth is more, the speed also very high. This is the fiber optic cabling now. That's why which is carries the data in the form of the light. This is the data can be transmitted in the form of the light that allow the fiber optic cable to carrying the signals at a higher speed. The speed is very high. The light signals can be transmitted very high the speed. The longer distance means now the advantage is a longer distance. So that is a fiber optic cable carries the data at a long distance are compared with a copper cabling. Copper cabling, suppose if it is transmitted to 20 kilometer now, this is the fiber optics can be transmitted to more than the 20 kilometers. More than 20 kilometers. That is a longer distance. Longer distance now we can transferring the signals in the form of the light. Fiber optics means in the form of the light that can be transmitted. Better reliability. Fiber optics reliability is more than compared with the copper cable. Reliability, copper cables compared with the copper cable, the reliability is more, as it is so this as temperature is changing, so the reliability should be the increased. And thinner and lighter. Now if you see in terms of the thinner and lighter, fiber optic cables is a very thin and light. Lightweight in terms of the very lightweight. So it can be withstand more pull pressure than the copper wire. So this is a thinner, very light. These are the fiber optics are very lightweight. The cable. This cabling is a very lightweight the cabling. Here for this these two are the textbooks, the data communication and networking and a computer, the networks of 5th edition by the Tenenbaum and the Frozen. These two are the textbooks for this topic. That is the OSI model and transmission media. So this is about the transmission media. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.